Hey guys, so today we're going to be writing sinusoidal functions based on a graph that is given. So it's really the reverse of what we've been doing before. Instead of given a graph, instead of given an equation, we have the graph. Now we have the graph and we have to write the equation. So a little warm up, if you consider the graph on the right, and let's say you have to come up with an equation for this graph, for the sine wave. It could be sine, it could be cosine, right? And if you use your calculator or Desmos to graph all of these functions on the left, what you're going to notice is that all of these functions give you the exact same graph on the right. This is the most obvious one. The most obvious equation for this graph would be just sine of x because it follows the perfect sine wave. There's no transformations, right? But remember we had said that, well, the sine function is really the cosine function, but shifted over. So if on Desmos you graph the cosine of x minus pi half, so if we shift the cosine function to the right pi half units, it's going to overlap perfectly with the sine function. And similarly, if I take my regular sine function and I shift it 2 pi units to the right, that's one full cycle. Again, it's going to overlap everywhere with the original sine function. So the point of this is just so you know that given any sinusoidal graph, there are infinitely many equations that you could write that would work. And so what I recommend is that you write an equation that is the most obvious one to you, okay? And your equation will always follow one of these four forms: y equals a sine bx or a cosine bx if it's got the amplitude and the frequency, and then if you got horizontal shifts or phase shifts and vertical shifts, then you got to add your h and your k values in. So let's look at an example, and again I'm going to have two examples here, but if after looking at the first example you feel like you're good, then you can go ahead and skip over the second example. So steps, my recommendation is to start with the easiest thing that you can identify, which is the amplitude and the wave axis. Now remember, the amplitude is half the distance between your highest and lowest point, right? It's the distance from your high point to your midline and the distance from your low point to your midline. So a couple of ways you could do this. You could just, since it's half the distance between your high and low points, you could just take your highest point and your lowest point, subtract it, find the difference, and divide by 2. Or you could just draw in, if you can identify where the midline is, you can kind of just draw that in. So for this one, I think the midline is right here at 3. Okay, and if I check using my high and low point, my y max seems to be at 4. That's the highest it gets to. That's 4. Right, minus the low, which is just 2, divided by 2. That would give me an amplitude of 2 divided by 2 is 1, which makes sense because if you look from your midline to your high point and from my midline to my low point, it's exactly 1 unit. So my amplitude A is 1, so that part of the equation is all done. Next step is to identify the period in order to find the frequency B. So that B value is in the equation, but that's not as easy to tell, right? How many full cycles can I see in a 2 pi period? But what's easier to identify is what is the horizontal distance that it takes to draw one full cycle? What is the period? And so once we find the period that we can see from the graph, the frequency is just 2 pi over p. Remember, these equations to calculate period and frequency are interchangeable. So depending on which one you want, you're just doing 2 pi divided by frequency to find period and 2 pi divided by period to find frequency. So in this case, we're doing the other way around. We're going to look at the graph and identify the period and calculate the frequency. So the easiest way to identify the period is, remember, the period is how long horizontally, what's the horizontal distance that it takes for my graph to repeat, right? For one point to be at the exact same location as the other point and as another point on the wave. And the easiest way to do that is to just compare the distance from 2 high points or 2 low points. So this is a high point right here. And the next time that my graph is at the exact same spot after one full cycle is right here. And so this is my period. So let's calculate what that is. It looks like my graph horizontally is scaled by 0.5. So this is going to be 1, 2, 3, 4, 5, 6 units. Looks like my period is 6. Okay, takes 6 units to complete one full cycle. And you can see that this is my one full cycle. And certainly you can do the same. If you take your two low points and find a distance between them, you would get a period of 6 as well. Okay, so the period of 6, so that means my frequency, B, is going to be 2 pi over 6, which reduces to pi over 3. So that's my B value. And then the last thing I need to figure out is whether it's easier to write a sine or cosine function. Now for your practice, I'm going to have you write both. Okay, so you have to figure out how to write a sine function and a cosine function. Normally it will only ask you for one, but we're going to practice writing both. So for the cosine function, what you want to do is you want to find the y-intercept before the translation, which is normally the highest point, 0, whatever the amplitude is, and figure out how many units it moved to the left or right, which is your phase shift. So basically, you want to find where your starting point of your parent cosine function normally is. Okay, and normally, where it is now, normally it's at 0, a, this high point, wherever the amplitude is. So I want to see where that got shifted to the left or right if it did, because that's going to be my h, my phase shift. And then if you're trying to write a sine function, well, you know your parent sine function looks like this. Axis high, axis low, axis. So again, this starting point of your first cycle, where did it get shifted to the left or to the right? That is your phase shift. That's your h, right? And then your k is just your amplitude. So going back to my amplitude over here, well, your k is not your amplitude. Your k is where your wave axis got shifted up to. I know that my k value is at 3. So the only thing that I'm missing in my equation is my h. Okay, so let's start with the sine function. If I want to draw one full cycle of my sine function, let's see where that would start. I know that my parent sine, again I'm going to draw it over here, is axis high point, axis low point, axis, right? So where is the starting point at? I'm going to say it is right here, looks like right here, because then it hits my high point, comes back down, hits the axis, right, and then low point hits my wave axis, and then here's one full cycle of my sine. So it looks like instead of starting at 0, it got shifted over to the right half a unit. So that's going to be my h. So I have all of the information to write my sine equation. My sine equation is going to be y equals, okay, and there doesn't seem to be any reflections, right, based on my graph, so I don't have to worry about negative. My amplitude is just 1, right, my amplitude is 1, and so it's just 1 times the sine of my b value is pi over 3, okay, times x. Now I shifted to the right half a unit, so that's going to be x minus 1/2, and then plus 3, because I shifted my whole wave up 3. Okay, so that is my sine graph, my sine equation. If we do cosine, let's again go back to my graph. Oops, here it is. Okay, so now cosine, I'm going to highlight this, I guess, in green. cosine, my parent function, again, know what that looks like. Starts with low, hits my axis, high, hits my axis, low point, hits my axis, and then back to high. Okay, so where did this point go? Instead of starting at 0 on x, it looks like it started right here. This is my first point for my cosine cycle, and then it hits the wave axis, low point, wave axis, high point. And so this is one full cycle, and it looks like it shifted to the right. My phase shift is 1, 2. It shifted 2 units to the right. Okay, and that's my h. So let's go back and write my cosine equation. This is going to be y equals, amplitude is still 1, cosine, period is still the same, pi over 3. Okay, and now it's x, and I shifted, what did I say, 2 to the right, so that's going to be minus 2 plus 3, and that's my cosine equation. So your sine and cosine equation are really very similar. Amplitude is the same, a is the same, b is the same, k is the same. The only difference is your phase shift, left and right, because remember we said cosine and sine are basically the same functions, but shifted left or right of each other. Okay, so if you feel like you're good, then you can stop here. If you need one more example, we're going to do another example together. All right, so here's another example. The same exact thing. I'm going to start by identifying my amplitude. I'm going to take my high and my low. So high looks like it's at 5. I'm going to subtract my low. So it looks like my y-axis is scaled by a half, right? Half, 1, 1.5, 2, 2.5. So it looks like my low is at 1 and my high is at 5. So 5 minus 1 is 4, divided by 2 is 2, amplitude is 2, and my wave axis is right here. That's my k value. Right, let's make sure that this gives me 2 units from the midline to the high point. So 0.5, 1, 1.5, 2. Oh, my mistake here. My low point is at negative 1. So it should be minus negative 1, which should give me a plus 1. Low point is at negative 1, so 5 minus negative 1 divided by 2. So that's going to be 6 divided by 2, which is 3. Amplitude should be 3. All right. And so I'm going to go ahead and draw my wave axis, which looks like the middle is about right here. And let's just make sure my amplitude is 3. So from here to here, that looks better. From the midline to the high point, 0.5, 1, 1.52, 2.53, there we go. And then same thing from midline to my low point, 0.5, 1, 1.52, 2.53, there we go. Okay, so amplitude is 3. My k value is my wave axis, which is at 0.5, 1, 1.52. And my amplitude is at 3. Okay, so then from there, let's find the period and the frequency. So period we can identify from the graph, and then frequency we're going to calculate based on my period. So again, let's take the 2 high points or the 2 low points, whatever you want to calculate. So I'm going to take my 2 high points here and here, and the distance between them is going to be my period. And so it looks like my x-axis, 0.5, 1, 1.52, 2.5 is scaled by half again. So this distance is going to be 0.5, 1, 2, 3, 4. Looks like my period is 4. Okay, and then frequency is 2 pi over the period. So 2 pi over 4 is going to give me pi over 2. That's my frequency. All right, so I've got my A, I've got my B. I've got my k, and the only thing left is my h, my phase shift, and that's going to be different depending on whether I want sine or cosine function. So looking at this graph, if I only have to write one equation, I would probably pick cosine because it kind of looks like a cosine already, all in the right places, right? High point starts off with a high point at 0, and then it hits my wave axis, and then it goes down to a low point, and then it hits my wave axis again, and then it goes back up to a high point. This right here is one full cycle of my cosine function, and it starts at x equals 0, so it didn't even shift left or right. Okay, so for my cosine equation is very easy. I'm going to do it over here. It's going to be y equals, and again, no reflection, so no negative. Amplitude is 3, so 3 cosine of b is pi over 2 x. Okay, no horizontal or phase shift at all. And then just plus 2, shifting everything up 2. That's my cosine. Now for my sine equation, again, I know that my parent function for sine starts on the axis, and then high point, axis, right, low point, axis. So where did this first point go? All right, so I could, if I look for this first point, there's one right here where it is hitting the wave axis and then increasing at the same time. There's one point right here. This point, it's hitting the wave axis and increasing, going up. That could be that starting point, or it could be this point right here. Okay, so whichever one you pick, it really doesn't matter. If you pick the one on the right, you're going to be shifting to the right. If you pick the one on the left, you're going to be shifting to the left. Both are accurate. I'm going to pick the one on the left just because it's a little bit closer. So I'm going to pick this one, and I'm going to say, okay, so this is the start of my first sine cycle, and then it goes up, hits the high point, comes down, hits the axis, and then hits the low point, and then here's the axis. So this is one full cycle. And so instead of starting at x equals 0, it is just starting at x equals -1, right? It just shifted 1 unit to the left. So my sine equation is going to be y equals 3 sine of pi over 2 times, I shifted 1 unit to the left, so that's going to be x plus 1, and then plus 2. And that's my sine equation.